for that. Okay, frame of reference and relative velocity. So you want to see what is this? We better do a question. Okay, just explaining what is that here, you see. Velocity of the plane relative to the Earth is velocity of plane relative to the air plus the velocity of the air relative to Earth. Okay, the thing is that if the plane is moving, right, with some velocity, and then the air has pushing the airplane, right? You want to see at what velocity someone from Earth see this airplane moving on. So this is the velocity of the plane respect to air. Let's say the engine is working and doing 3 kilometers per hour, I don't know. And this one is 2 kilometers per hour, the wind is blowing. So of course, addition of these two vectors will be the velocity as someone on Earth will see this airplane is moving. So this is the V of air respect to the Earth, okay? Okay, now how do we come up with this formula algebraically? Pay attention, V of the plane respect to Earth. This is addition of the two velocity, right? Velocity of the plane, you need to add it to the velocity of air or wind. Then the thing is that you have to put, so PE, so sorry. Since this is PE, right?
Yes.
Is that VP and here is E.
PE.
Okay. Now, the element is air or wind. You say PA here and PA here. A put in front. You put at the end. Here you put A and at the beginning. Or you can say that if you have that A and A, which is the common point between them, is cancelled, right? And it's just PE. You see PE. So this is algebraically. So this is the velocity relative to ground is, okay, let me just see that. If velocity relative to the air is 430 and the air's velocity relative to ground is 90, the air velocity relative to ground is AE, and the plane velocity relative to the wind is 430. You added these two vectors. Make sure that you are adding them as a vector. As you see here, VP is VPA, VAE. So see, if when the A and the A here that they have in common cancel, it's going to be PE, right? The same thing happening there. See, if you have M and M cancel because they are beside each other, here is N and N cancel because they are beside each other. So the total answer is VLO. The same thing here, W and W are beside each other, they cancel V, as you see here. The E and E cancel, and F are beside each other, they cancel. It'll be VDG, as you see, is VDG. Is this algebra? You're adding the vectors. Okay, let's just look at this question. An Olympic canoeist capable of traveling at a speed of 4.5 meters per second in a still water is crossing a river that is with a velocity of 3.2 meters per second east. Okay, so this is the river that you have, and If there is no water, of course, this is moving at 4.5 meters per second. This going to the east, what is that? The flow in the water is 3.2 meters per second to the east. The river is 2.2. It's gonna kind of 220 meters wide. If the canoe aim northward, what is the velocity relative to the shore? If you're trying to cross, right? You're paddling in this direction and you're paddling with this speed, right? 4.5. But what exactly happened when someone look at you from the shore, right? But this person, see, you aiming forward, but this person is seeing that you're drifted by the current to this direction and you will land up here. I know you aimed straight, but because of the current push you, you land here, not here, okay? The first question, how long does the crossing takes? Okay. This is a point. We have two directional motion, X and Y direction, and they are independent, like a projectile, right? The time gonna be common between the motion in X and Y direction. So to find time, I can use the X direction or Y direction to find that. So in Y direction, I have a velocity, and I have a distance, right? I use this to find time. The time gonna be delta Y divided by velocity. Delta Y is 220 divided by 4.5. This is the time. Let me just see what they have for this time things. Is here 200 is 49. Okay, just going back here. Is 49. 49 seconds. Actually, didn't do the first one. If the canoe aims northward, what velocity relative to the shore? So it means what is this velocity that you see here? You use the Pythagorean theorem, right? So the velocity that a person see the canoe relative to the shore means the velocity of the person relative to the earth gonna be a square root of 4.5 power 2 plus 3.2 power 2. Also the angle, then you can use a calculator. The angle theta is opposite to the this opposite adjacent. So tan inverse of 3.2 divided
over
by
4.5.
4.5. Very good, thank you. Now you'd find out, and then you can say that the direction of the canoe moving, and you find the time just using one direction. Where the landing happening. Now, since you have time here, the time between the X and Y direction going to be in common, right? So that was B. Now C. So here I want to find this delta X. Again, delta X, if I rearrange it for the delta X, going to be velocity multiplied by time. Velocity, we have 3.2 multiplied by time that you got it from the previous step. That would be the delta X. So I'm gonna just confirm that's my answer with you. So here is gonna be 5.5 meters per second, the one that we did here. 5.5 meters per second, and the angle is 35 degrees. You want to do that, you have to say north, right? You have to say north, 35 degrees east. This is the direction of that, 35 degrees east. Okay, So yeah, that's good. Now, the last one is said, if the canoe landed directly across the starting point, what angle would the canoe have been aimed? Okay, I'm gonna put that note here. Again, if you start here and you land here, you should paddle in this direction. Why? Because the water push you east. You have to push the west, so you can be directed to the east. Therefore, if you aim here, then you're possible to land straight forward. Any question? Is it clear?
Yeah, I'm clear. So
Now, the velocity that you're paddling in the west gonna be 3.2, and the speed of water is 4.5. Using the Pythagorean theorem, you can find the velocity that a person in a shore see you. Also, at what angle you need to do. This is tan inverse. Actually, you have to do sine inverse, right? Theta is opposite over hypotenuse.
yeah,
Sine inverse of opposite is 4.5
4.5
divided
over
by
3.2.
3.2. And that would be the angle that you're aiming. Or you could find the Pythagorean theory, find this side, use the tangent, but I don't see necessarily. Let's see what they used here. Yes, they use sine inverse. Sine is opposite. Did I choose this one correctly? Maybe they made a mistake. Let me just go to the question again. What is the, oh, guys, the velocity of the water, I put it wrongly here. The velocity of the water is 3.2 and the person paddling is 4.5. Okay, make sure. So this is true. This is 3.2, the velocity of the water. 4.5 is paddling. So it's going to be opposite over hypotenuse is 3.2. I need to correct that. Is 3.2 divided by 4.5. But you got the problem, right?
Yeah, yes.
Okay. Amazing. Let's just move on. So here is another. The airspeed small plane is 215 km per hour. The wind blowing 57 km from west. If you said from west, means the wind going to the east because it's from west, right? Is 57 km per hour. And the velocity of the small plane is that. Velocity of the plane relative to ground. If the pilot keep the plane 34 east of north, means north 34 to the east. So this is what you have, and it's 250 km per hour. So you know that the airplane added to the wind is the velocity I see from the ground, because the wind is pushing the airplane. So you need to add these two velocity. I did talk to you about addition of the vectors in components. You put them in the X and Y component and separately add them. And at the end, you put them together. You remember that?
Yeah.
Okay. They did it through using the geometry, but I don't want you to use the geometry. Just do the components. So the helicopter flying, their average wind velocity is given. Need to achieve the velocity of that relative to the ground. What necessarily velocity relative to air? So you know that the velocity of the helicopter respect to the ground or earth is the velocity of, so I just put H, velocity, I put E here, and I put air here, and I put air here. So velocity of a helicopter respect to the air is the one that you want to find, is the question mark. So velocity of the helicopter respect to the air. What velocity you need to move? And the velocity of the helicopter, what velocity you see is the one that you
Minus.
want to achieve. Plus, minus, because you want to bring this one to the other, minus the velocity that air has, or the wind. Right? You minus this to velocity. Again, you write that in the component x and y. Component x and y, make sure you negative that, you minus their components, right? And then put them together to find the velocity. This one. Got it?
Yeah, yeah.
Okay, so here is just do the question that has answer number 2, 3, and 4.
2, 3, 4. Page